Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And remember, as a caveat, this is considered easy by the people on the forum of Logic Masters Germany, where there's a lot of really smart people. So take the easiness with a grain of salt. And today's puzzle is called Hit Me Up by Ratfinks. And here are the rules. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and box. Hit points. Clues outside the grid give the sum of all cells that contain a digit equal to the distance of that cell from that clue in the row, column, or marked diagonal. Okay, those are all English words, but I don't. It's not translating right now for me. Okay, let's look at the example. For example, a 3 in row 3, so row 3, column 2, okay, would count toward the 14 clue in column 2, and any other number would not. Oh, I see. Okay, so it would contribute 3 to the 14 because it's 3 distance away from the 14 in that direction. Therefore, actually, you would have, if this is 3, this would contribute also 3 in the diagonal for this direction because it's 3 away from 6, this diagonal 6. But it would not contribute to the 6 diagonal because it's not 3 away from the 6 diagonal. I see. So clues outside the grid gives a sum of all cells that contain a digit equal to the distance of that cell from that clue in the row, column, or marked diagonal. So again, this would be 7 away, so this would have to be, this 3 would not add up, right? Or for this 6 diagonal. For this 6 diagonal, it would, because it is 3 away. And then if you move the 3 here, then it would fit for the 14 because it's 1, 2, 3 away from the 14, but it's not 3 away from the 7. Okay, I think I get it. Okay, and those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, not sure how to exactly tackle this. Hmm. So we know that these are sums of digits that are certain, that have to be the same distance away as the number in the cell. Okay. So 14 must have at least 2 digits, obviously. 25, 22, 15 all have this. Okay. This is 6 either way. So it could technically be 1, 2, 3 in that direction. That's possible. Hmm. This is 15 and this is 25. Okay. This is 15 and this is 15. This is 11 and that's 15. 5 and 13. So anytime there's a 5, that's interesting, right? Because it's directly in the middle of essentially a whole bunch of stuff. But I don't know if that's helpful. Yeah, I don't really have any intuitions on this right now because I haven't done, this is a completely new rule set for me. I think I've done something kind of similar with the hit points, but wasn't like everything was hit points. So I don't have any like major intuitions here. Okay, for the 5, that means one of these 5. It has to either be 1, 4, 2, 3, or 5. Interesting. The diagonals right now I don't think are that helpful. I think it has to actually concentrate on rows and columns. 25. What's the minimum for 25? It would have to be 1, 7, 8, 9, right? And then you could have, I guess, 4, 5, 6. You would have to be 4, 5, and 6 if that's the case. Okay, so maybe this is the way to approach it right now. So what are the possibilities to add up to 28, 25? 1, 7, 8, and 9, which would force this to be 4, 5, and 6, because 2 and 3 are no longer allowed here. So that could be valid. 1, 4, 7, 8, 9 with 4, 5, 6. What about 2? So it would be 2, 6, 8, and 9. 1 is no longer useful. 3, 6, 6 doesn't work, obviously, so it'd have to be 3, 5, and 7. So 2, 6, 8, 9 works with 3, 5, 7. What about 3? If you have 3, 5, 8, and 9, that just doesn't work. If you have 3, 5, 8, and 9, the only possible ones would be 4 and 6 that are valid, and that's not enough. So it cannot be 3, 5, 8, 9. But what if you have 3, 6, 7, 9? Then 2, 5, and 8 works, but that's the only one, because 6 is already taken, 7 is taken, 9 is taken. Yeah. So it has to be 2, 5, and 8. Oh, wait, hold up. No. 3, 5, 8, 9 I think also works. 3, 5, 8, 9. Because it could be 4 and 6, right? 4, 5, 6. You already have a 5 here, right? The 5 counts both ways. Yeah, as I said before, 5 is interesting because it can work in multiple ways, but everything else cannot. So 3, 5, 8, 9 works with 4, 5, 6. So far we've always had a 5 in the middle. We tried 3, 6, 7, 9. That works with 2, 5, 8. So 3, 5, 8, 9, 3, 6, 7, 9. Okay, those are only the possible 3s. What about 4? 4, 5, 7, 9 works with 2, 5, and 8. So that works. It's 15 this way and 25 that way. Right? 9 plus 9 is 18 plus 7 is 25. Yep. So 4, 5, 7, 9 works. 4, 6, 7, 8. That would have to be 1, 5, and 9, right? 1, 5, and 9 is the only one that works. 7, 8 are already taken. Yep, it has to be 1, 5, and 9. So 4, 6, 7 also works with 5. So far it's all 5s and stuff. For the 25. So 4, 6, 7, 8. We 4, 5, 7, 9. It cannot be 4, 4, 8, 9, so that doesn't work. What about 5? 5? 5 goes with 6. That's 11. That doesn't work. 5, 7, 12. 5 and 6, 7, and 4, 9 are already taken. So 5 and 8. That's 13. I would have to have 3, 9, and 5, 7. Okay, so yeah, we've done all the different variants, and each one, the 5 is in the middle. Oh. So that means this has to be 1 and 5. Right, so for all the variants of 25 that we could find, which was 1, 7, 8, 9. So 1, 7, 8, 9 had to go with 4, 5, 6. 2, 6, 8, 9 had to go with 3 and 7. 3, 5, 7. 3 goes with either 5, was it 3, 3, 5, 8, 9, which worked with 2, 5, 4, 5, 6. 3, 6, 7, 9, which works with 2, 5, 8. Right, so this one's always, yeah, this is always going to be 5 because it's always going to require 5 for both 25 and 15 to work. And we did 4 with 4, 5, 7, 9, and 4, 6, 7, 8. And those 4, 5, 7, 9 obviously has 5. 4, 6, 7, 8 requires a 1, 5, 9 triplet the other way. So this is always 5, which means this has to add up with a 1. And the only places can be 1 are here and here for this diagonal. This one is a little bit trickier. You need 2 that add up to 6, or 1 that adds up to 6. This adds up to 10. We have a 10 that adds up this way and a 10 that adds up this way. Okay, so this is always 1. This is always 1. So this is at most 1, 7. So this can no longer be 1 this way. So 1, 7, 8, 9 is ruled out here. Also, the 1, 5, 9 is ruled out here. So it still could be 2, 6, 8, 9, right? 2, 6, 8, and 9. And that would require it to be with 3, 5, and 7. So then this would be 1, and that would be 4. So 2, 6, 8, 9 works. What about 3? 3... None of this... This can't be 2. This can't be 3. This can't be 4. This can't be 2. This can't be 3. This can't be 4. So, okay. This is 3, 4, 5, 6, 7, and 9. Because it cannot be 8. So this cannot be 2. So this one cannot contain a 2 here. And it cannot contain an 8 here because it's, yeah. So all of these are no longer valid. So let's mark the ones that we have with valid, valid, valid. These cannot be. So this is 2, no 3, 4, 5, 6, no 7. It could be 8 or 9. And this is, could be 1, 2, 3, no 4, no 5, obviously, no 6, 7, 8, 9, 1, 2, 3, 7, 8, 9. This is 3, 4, 5, 6, 7, 9. This is 2, 4, 5, 6, 8, and 9. So, right, they cannot be valid for either way because it's, they have both diagonals, or I guess it would be this way. They have both diagonals pointing in. So they cannot fulfill any more because it's 1, 5, and 1, 5. So we tried 2, 6, 8, 9. What about 3? 3, 5, was it 3, 5, 7, 9? Also works. 3, 5, 7, 9 works with 4, 5, 6. So 3, 5, 7, 9, 4, 5, and 6. 2 cannot be either here or here, so 2 would have to be... you actually, no, you could work with 2, 5, 8 too, right? 3, 5, 7, 9, 4, 5, 6 works. 3, 5, 7, 9 could also work with 2, 5, and 8. So that does actually work. 7, 9 works with 4, 5, 6. In which case, oh. 3, 5, 7, 9 doesn't work. Right? Okay, let's show why that doesn't work. Say this was 3, 5, 7, and 9. Either this is 4, 5, 6 to fulfill this 15, or it's 2, 5, 8. Any other combination doesn't work, essentially. Because you have, yeah, you can't have 2, 4, 5 with the 6. Doesn't, I mean, that doesn't, yeah. So, either 2, 5, 8 is there. So say it was 2, 5, and 8. Well, where is the 4 and the 6? One of them has to be in the appropriate position, right? Because if the 4 is here, it's appropriate for this, which makes it now add up to 19. Or if it's here, it basically is contributing to here, which adds up to 29. And this one of the 4 or 6s has to be in this position, and they would contribute either way. So it cannot work with 2, 5, 8, and the same reasoning holds for 4, 5, and 6, right? If this is 4, 5, and 6, what about the 2 and 8? One of them has to be in one of these two spots. Therefore, 3, 5, 7, 9 does not work. 3, 6, 7, 8, I think does, though, right? So 3, 6, 7, 8. Wait, that doesn't add up. No, it'd be 3, 6, 7, 9. 3, 6, 7, 9 does add up with 2, 5, and 8. And then you would have 1, 4 here, right? Which neither of them count toward either sum. So 3, 6, 7, 9 works. So this could be 3, 6, 7, 9. And then there would have to be with 2, 3, 6, 7, 9. Right, works with 2, 5, and 8. Which would be 1 and 4 here again. So that's the 3s, right? So we did 1. There's only one combination starting with 1. That would be 1, 7, 8, 9. You have 2, which only has one combination. It's 2, 6, 8, 9. 3 has two combinations. It's 3, 5, 8, 9, which we showed does not work, and 3, 6, 7, 9, which we showed does work. 1 is removed again. The 1, 7, 8, 9 is removed because this is 1, and now there's no 1, 7, 8, 9 possible. So now 4. 4 has two combinations also. 4, 5, 7, 9, which I'm suspecting won't work, and 4, 6, 7, 8, which also doesn't work anymore. Because if you have 4, 6, 7, 8, you need 1, 5, and 9. But this one is already taken. So 4, 6, 7, 8 does not work. Now let's try 4, 5, 7, 9. So this is 4. Okay, so now we try 4, 5, 7, and 9, right? That adds up to 5, 7, 9 adds up to 21. With 4 is 25. You could do 2, 5, 8. Actually, that does seem to work okay. 2, 5, 8, 4, 5, 7, 9. Then this would have to be the 1. So 4, 5, 7, 9. You only have the 8 and the 6. You can't have 1 anymore, so it can't be 1, 6, 8. 1, this 1 is removed. The 6 is not possible, therefore it has to have an 8. It has to have a 5. It has to have a 2. But you have 1, 3, and 6. So 3 and 6 could be here. 1 and 6 could be here. And this could be 1 and 3. So 4, 5, 7, 9 works too. 4, 5, 7, 9 works also. And it works with 2, 5, 8 specifically. Because you have 1, 3, 6. You have to have an 8 there, essentially. 6 is no longer valid. So then this would have to be 1 or 3 because it can't contribute to either hit point set. This would have to be 1 or 6, and this would be 3 or 6. So either way, we know the 9 is here. So this cannot be any longer 1. It could be 1, 2, 4, or 1, 6 this way to add up, right? 1, 2, 4, or 1, 6. So this one works this way. Oh, wait. No, I'm overcomplicating things. I'm overcomplicating things. Okay, this cannot... The 5 counts both ways. I totally forgot about that. The 5 count both ways, so you can't have 2, 6, 8, 9, right? The 2, 6, 8, 9 doesn't work. because it doesn't count both ways. And then we try, okay, so 2689 doesn't work anymore because the 5 is in the middle either way. Yeah, okay, sorry, I'm not used to the hit point rules. So um, yeah, so then it has to have a 5 involved. So the other 3 digits add up to 9. Or sorry, not 9, 20. So it's either 389 or 479. Because all the other 20 sets that with 3 digits have to add up to uh, oh, it could be 4 digits that add up to 20. I didn't think about that. Well, you can't have 1 anymore. So 1 is never involved then. Um, you could have like 2837. Huh, okay, I didn't think about that. That's definitely something to keep in mind then. So it could be you have, say you have 2, 3, 7, and 8. Actually, then that was a bad assumption. That was a wrong assumption there. Because I only calculated for the 4 sets that add up to 25. But there's could be some 5 sets that add up to 25. Oh no. Um hmm. This is, yeah, we have to reset then. Um we don't, okay. We don't necessarily, but because we haven't tested any of them though. That's the problem. Okay. Okay, so what happens if we have uh I might be overcomplicating this. I don't know. Maybe I should just do this. Okay, there's 3 here. It's either 3 or it's 1 and 2. And then none of the other ones work. So this is either it cannot be 1 or 2. Right? If it's 1 or 2, there's no way you'll get 3 that adds up to 3 then. So this is 3, 4, 5, 6, 7, 8, 9. That's not very helpful. 25. 4 digits, 5 digits that add up to 25. Can't be 1, 2, 3, 4. What's the, yeah. Can we do anything without a 5 is the question. That's what I'm trying to think. Because otherwise then it simplifies things a lot to have the 5. Um, I don't think this is as easy as people think. I think people just made the assumption that I just did. 22, you could have 1, 2. Well, it doesn't matter. There's nothing else that counterbalances the 22. There's nothing else that counterbalances the 3. Hmm. Yeah, the 25 was the most limiting factor that I could see. I think we have to continue down that path. Okay, what are the 25s that count? 9 plus 4 digits that add up to 16. So 1, 2, 5, 8, 9? But that includes a 5. So anything that doesn't have a 5, we don't really care about, right? Because we want to show that you have to have a 5 in this spot. So anything without a 5, we're trying to solve for. So okay. Say you have a 9. So say you have 9 and then 4 other digits. If you have a 9 and 4 other digits, there it's 16. 4 digits adding up to 16. You could have 1, 2, 5, 8, but that has a 5, so we don't care. 1, 2, 6, 7 is possible. So 1, 2, 6, 7. You no longer have access to the 3. The 2 is not valid. it would have to be, yeah, 6, 7, 5 are the only valid ones, and that doesn't add up to 15. So 1, 2, 6, 7, 9 does not work. So that's 3 plus, yeah, 6 is 9, plus 9 is 18, plus 7 is 25. Yep. So 1, 2, 5, 8, 9 we don't care about because that has a 5 in the correct position. 1, 2, 6, 7, 9 does not work. Okay, 1, 3, 1, 3, 5, 7, 9 is fine, but that has a 5 in the middle, so that still says that 5 is in the middle. So without 1, 3, 5, 7, 9, 1, 3, 4, 8, 9. Let's try that. So 1, 3, 4, 8, and 9. Does that add up? Yeah. In which case 3 and 4 are no longer valid. You have 5 and 8, which doesn't even work. So yeah. 1, 3, 4, 8, and 9 does not work. So that's all the 1, 2s and all the 1, 3s with a 9. Because we just did 1, 3, 5, 7, 9. Can't be 1, 3, 6, 6, right? So that's all the 1, 2s and 1, 3s. What about 1, 4 with 9? Is that even possible? You have 1, 4, that's 5. So this has to add up to 10, which means that you have to have 2, 8, or 3, 7, which we've already covered. Oh, wait, no, that's 14. So it'd be 2, 9, 3, 8, which we already have. 5, 6, which includes a 5, so we don't care about that because then the 5 still has to be in the middle. Okay, so that's all the ones added with 9, right? Because 1, 5, 6, 7, 9 is not equal to 25. It's greater than 25, and it will always be greater than. So all the ones are taken care of. So the 5 always has to be in the middle for any of the ones. What about 2? So if we try 2, 3, 2, 3, and 9 adds up to 14. So another 11 set. 4, 7 works. The only ones possible now, 2 doesn't work, 4 doesn't work, 5, 9 doesn't work, so that doesn't work. What about, then 5, 6, you have a 5, obviously, so that doesn't matter. 2, 4, that adds up to 15. You cannot have 1, 9, it would have to be 3 and 7, which we just already tried. So 2s are now accounted for with the 9s. What about 3? 3, 4, 5? Well, again, we're trying without a 5, so this adds up to 7. But the problem is that you would have to have a 2, 7. Yeah, you would have to have a 2, 7 or 1, 8, and we've already tried both of those options. So that doesn't work. Or we've already tried all those options. So all the 3s are taken into account. So everything's taken into account with a 9. What about with just an 8? So we have 8. We could have 1. What's the minimum with that? Without a 9. Because we've already accounted for all the values with 9 being in the right place. So 7? So we try all the 7s with that. So 7, that'd be 1, 7, 8 is 16. So the rest would have to add to 9. The only ones that could be 4, 5, which we have the 5 in the right place, or 3 and 6. So 6, 7, and 8 are out going this way. 5 is the only one, and then 1 is out. So that doesn't work. Yeah, so 8, 7 are all accounted for. What about 8, 6? 8, 6, 5, 4. Oh, wait, no, that was 8, 1. 8, 7, 1. What about 8, 7, 2? Yeah, let's try it that way. That's probably easier. This is 17, so we have 3 and 5, which we don't care about. 1, 7 doesn't work. 2, 6 doesn't work. With 2, 7, 8. And then, yeah, that add up to 8. Yep. So 2, 3, 5. There's a 5 in the middle, so obviously we're okay with that. 8, 7, 3. So this now adds up to 18. So we have 1, 6, which we already... Actually, have we already had one of those? I don't know. Oh, yeah, we did have 1, 6. We already saw what happens with 1, 6. 2, 5. We also did that, and there's no 3, 4. So then 8, 7, 8 sevens are all accounted for now. So 8, 6. Say we have 5. This adds up to 19. So then you would have 2 and 4, but you have a 5 in the middle, so you don't really care. 8, 6, 4. This would be 18, which we have to add with 7, so it would be 2 and 5, so that's already accounted for. Yeah, I think everything's kosher. So 5 does have to be in the middle, because every version that we've seen that doesn't break has a 5 here. But it was a little bit more complex than, I don't know, that didn't seem easy per se. So this is 5, which forces this to be 1 and this to be 1 to add up to 6. Otherwise, there's no other combination that actually works on the diagonals. So these are all kosher. So yeah, maybe I shouldn't have, I don't know. These can't be for either diagonal. Obviously the 1 doesn't work here. Huh, that doesn't tell us very much though. So yeah, here all the 1 combinations do not work. So was there any non-1 combination for the 5 sets? I don't think so, right? So obviously 1, 7, 8, 9 does not work because you also have an additional 5. 2, 6, 8, 9 doesn't work because you also have a 5 here. So it has to contain a 5, and then it have 4 digits or 3 digits that add up to 20. You can't have 5 digits that add up to 20. Or could you, actually? 5 digits adding up to... Well, you can't have a 1. So that would be 2, 3, 4, 6, and 7. So that doesn't add up to 20. So you can't have 5. Yeah, and I think it's... I do remember I was thinking of the six digits adding up to 25. But I think that's trivially easily to show that you can't have 15 the other way, right? Without a 5 in the middle. So yeah, I think that works. Right, because okay, let's just go through those then. Say you did have a 1, right? Say you had 6 digits, then unique digits add up to 25. You have 1, 2, 3, 4, 5, 6, which adds 21. 1, 2, 3, 4, 5, 9 does not work. So it would have to be 1, 2, 3, 4, 6, and 9. But then these 3 digits by themselves would be 2, 3, and 5, which don't add up to that. That doesn't add up to 15. So we tried 1, 2, 3, 4, 6, and 9. That doesn't work. What about 1, 2, 3, 4, 7, 8? Similar again. You have to have one that's above 5 to add up to 15. Right. So that doesn't work. 2, 3, 4, 5, 6. Actually, that might work. But you already have a 5 then, right? Oh no, 2, 3, 4, 5, 6 doesn't work. Sorry. 3, 4, 5, 6, 7 does work. We're basically looking for situations where you don't have a 5. Okay, so 25 that, so we did one. Okay, so 9, maybe 9 down. 9, 8. So let's try 9, 8. It's 17. So it'd be 4, 3, and 1. That add up to 8. And the problem is 8's already removed, and you have all 4 of those already blocked, so that doesn't work. So that's 9, 8. That's the only 9, 8 that could work. 9, 7. That's 16 with non-5s we're trying to get. So 16, so 9. So 6, 2, and 1. 1, 2, 6, 7, 9. But 6 and 7 now accounted for. Yeah, it just doesn't work. I'm pretty sure none of these work, so I'm just trying to go through fairly quickly. 9, 7, 4. I don't think works. No, we tried 9. Okay, 9, 3, 2, 4. 3, 2, 2, 3, 4. 2, 3, 4, 7, 9. The problem, yeah, none of these are valid. So then you don't have enough to make 15. Yeah. So 2, 3, 4, 7, 9 doesn't work. What about 6? That would be 15, so 2 digits adding. So we already taken care of 9, 7, and 8. So what about 8? If there's 8 and 7, the rest have to add up, so it could be 4 and 6. So it could be with 1, but then you have to have 5 and 9 again. So 8's, we're trying 5-digit cells, yeah. Which add up without the, or 6-digit cells. Oh, no, I'm getting confused. Yeah, we're doing 6 now, not 5. So we've shown all the 5s before. All the 5 sets that add up to 25. There's not many 6 sets that add up to 25. And then all of them probably contain, well, they probably don't work either way. Yeah, because you have to have at least 3 from 1 through 4 if you don't have a 5 to add up to 21, right? Say you didn't. Say you had 2 here. Then you have to have 3 that are 6 or greater, 4 that are 6 or greater, which doesn't work. 6, 7, 8, 9, right? Yeah, so that doesn't. So you're always gonna have one high. I guess, can you have one high and 2 lows? So 3, 4, 8. I don't think so, right? 3, 4, 8. That's the only one I could really think of. Because you need, like, a lot of lows here. 3, 4, and 8, and then you need... So let's see. 3, 4, and 8. So no 5. You don't have 7, you don't have 8, so those would be 9. Yeah, it doesn't work. So we know, again, so all of that was to show this has to be a 5 in the middle. Maybe there might be a more elegant way of showing that. I don't know. I'm not sure. This can't be 2 or 8 because it doesn't work either way on this diagonal. So this has to be no 1, no 2 or 8. 3, 4, 5, 6, 7, 9. Same here. This is 3, 4, 5, 6, 7, 9. This can't be 3 or 7. So it's 1, 2, no 3, 4, 5, 6, no 7, 8, 9. So this is 2, 4, 5, 6, 8, or 9. This can't be 4 or 6 or 5. So this is 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. We know there's a 5 here. There's a 1 here. This has to be either 1, 6 or 1, 2, 4. Ah, this can't be 1 and 2 anymore. Right? The 1 is no longer valid this way. So this can't be 1 and 2, therefore this has to be 3 here. Which doesn't work anywhere else, but anyways. This could be 2, 4, or it could be 1, 6. We don't know which. So none of, well, so this can't be 1, which we already knew because of that. This can't be 4, this can't be 5. So this can't be 4. Actually, we should probably try going this route. So we have 5, we have 20 that adds up 4. We can either have 4 digits that add up to 20, 3 digits add up to 20, 4 digits add up to 20, 5 digits add up to 20. Those are the only possibilities now. Let's eliminate the 5 digits adding up 20. That should be fairly simple. So you have to have 3 digits that are less than 5. So it could be like 1, 2, 3. Actually, no. So yeah, you would have to have 2, 3. Wait, hold up. 5 digits again. Okay, 5 digits adding up to 25. So you could have 1, 2. Like you can't have 1 anymore, right? So no 1's allowed. So you have 2, 3, 4. But you would have to have 9, 5, and 1 this way. So that doesn't work, right? If you have 2, 3, 4 here, that doesn't work. We know 1 can't be involved. And then to have 5 digits adding up to 20, you need 2, 3, and 4 at least, which doesn't work. So it can't be 6. No 6 digits this way. What about 5 digits without a 1? That's important. Then you have, so, sorry, 5 digits total adding up to 25, right? So it's 4 digits adding up to 20 with no 1. So it could be like 2, 3, 7, 8. I think that works, right? So 2, 3, 7, 8 works, right? And then you would have 4, 5, well, one of these would have to be 1. And this doesn't add up to 15 then. Because neither this nor this could be 1. And if that's the case, then this would have to be, yeah, so any balancing of this, like 2, 3, 7, 8, or 2, 4, 6, 8, the problem is 1 has to be one of those, which eliminates the possibility for 3 and 7 to be there. And we can't be 1 and 9, obviously. So, like, then it never adds up to 15 this way, going that way. So it cannot be 2, 3, 5, 7, 8, or 2, 4, 6, 2, 4, 5, 6, 8, or 3, 4, 5, 6, 7, right? Because then 1 has to be one of those. 2 and 9 would have to be with without one of its partners, so that doesn't work. Is there one without the 10 that way? So if you had, say, I think you would have to have, what, 5, 6, 7, 8? But then that's already greater than 25, right? So no, you can't have 5 digits that add up to 25 and still going this way, and then 15 digits. 3 digits add up to 15 going this way. So we've ruled out all the 5s then. Okay, so now it can't be 189, 1789, because there can't be a 1 here. Can't be 2, because it's 2689, which doesn't have a 5. So it's either 3, so it's either 3, 5, 7, 9. I think that's right. Cannot be 3, 6, 7, 8 because you don't have a 5. So 3, 5, 7, 9, which works with 2 and 8, or 4 and 6. So either of those seem to work. Wait, do they? Hold up. 3, 5, 7, and 9, right? So this is, oh no, it's not 7, 9. It's 3, 5, 8, 9. It cannot be 3, 6, 7, 9. Right, that's the one, yeah. So it would have to be 3, 5, 8, 9, which forces this to be 4, 5, 6. And then you have 2, 7, 1, 7, 1, 2, 7, or 1, 2, 7. So those all work. So 3, 5, 8, 9 works. And that's the only 3 possible. What about 4? 4, 5, that's 9. So this would add up to 16. So that'd be 7 and 9. You could have 2, 5, and 8. And that seems like it works. Yeah, and 136, 136, 136. Yeah, that seems to work okay. So either one of those works. So 3589. So 3, but if you have 3589, it has to go specifically 4, 5, and 6 this way. This can't be 7, so this is 1 or 2. This can't be 2, so it's 1 or 7, and this can't be 1, so this is 2 or 7. So that works. Or it's 4, 5, 7, 9. Because 4, 5, 7, 9. You have to have 2, 5, and 8. Right? 4, 5, 7, 9. This is no longer valid. You have to have a 2 then. So then this would be 2, 5, and 8. So 4, 5, 7, 9. You'd have 2, 5, and 8. This could be 1 or 3. It cannot be 6. This could be 1 or 6. It cannot be 3. This is 3 or 6. It cannot be. So it'd be 2, 5, 8 this way. And those are the only valid possibilities for this column 5. So we know now 9 has to be here. Okay. So from all that, we got back there. This cannot be 4 and 6 because the 4 and 6 has to be there. So this is valid either way. Right? It's either valid as the 4 or it's valid as the 6. And in addition, we know the 4 has to be here. So this cannot be 5. Interesting. This cannot be 1, 2, 5. It could be 1, 7 or 1, 3, 4. We don't know which. Okay, this can't be 3 because of this 3. Five is no longer valid here. Okay, so this can't be 5. So this is either 1, 4, which it can't be, or 2, 3. So this is 2, this is 3. Huh. So those are both there. So none of these other ones. So this can't be 1, obviously. That's fine. This can't be 2 or 3. This can't be 4. This can't be 6. Okay, for 13, you don't have a 1, you don't have a 2 or a 3. So it has to be 2 digits that add up to... So this has to be 4 and 9. Oh, maybe I was overcomplicating things. Because it cannot be 5, 8, cannot be 6, 7. So it has to be 4, 9 going this way. So this is 9. Okay. This is 2. So it must add up to 10. It's either 1. It can't be 1 anymore. So no 1. It can't be 2 and 3. Can't be 2, 4, 5, anything. So it has to be 2, 5, and 8, right? Yeah, so this has to be 8 then. Because this works as 2. This works as 8. We have 11 now. This can't be 1. Hold up. This is problematic. Oh, it has to be 5 and 6. Right. You can't have a 1. You can't have a 3. You can't have a 4. You have 2 digits here. This has to be 6 then. So then this has to be a 4. Which means this can't be 4. So this has to be 4 and 5 going this way. So it must be 4, 5, 7, and 9 to add up to 25, right? 9 and 9 is 18 minus 25, has to be 7. So this is 7. Then this has to be going this way. It can only... This is no longer allowed or is a valid hit point. So this is 2 then, and this is 8. So then we don't have 2 or 7, and this cannot be 3 anymore. So this is valid this way. These are not valid anymore. Either way. This is not valid anymore. This is not valid anymore. And this is not valid anymore. So this can't be 3, 4, or 9. There's no 6, obviously. This can't be... Well, we already knew it can't be 3. So this one's taken care of. This one still could be 1, 6 or 1... It can't be 1, 2, 4. So it has to be 1, 6. So this is valid. These are not valid. So 11's taken care of. 15's taken care of. Okay, this can't be 1 or 3. This can't be 3. This can't be 3. Therefore, this... Oh wait, this is not... There's no diagonal rule. So never mind. Yeah. 3 can't be here. 3 can't be here. So this is 4 and 9 to go for the 13. So this one's done. This one's done. This one's not done. This one's done. This one's done. So this one's done. This one's not. This one is. This one is. This one is not. Oh no, this one is. 4, 9. This one is. This one is. This is an 8, so it has to be either 1 or 3 or 4, right? Those are the combinations that add up to 12. So this has to be 4 because the 1 is already taken care of here. So this is 4. So this is the only, so this one's taken care of, technically. There's no 5 here. It has to be adding up to 9. It cannot have a 5. It cannot have a 4. So it can't be 1, 8. There's no 1 involved. So it can't be 1, 8. Can't be 2, 7 because this can't be 2. Can't be 2, 3, 4 then either because that doesn't work. Can't be 4, 5 because that doesn't work. So it has to be 9. So this has to be 9 then. So that's done. So we have 9 here. This cannot be 1, 5, or 9 or 1, 5, or 9. So it cannot, it could be 2, 5, 8 this way. Oh, this can't be 2, 3, or 4. Oh, it doesn't matter. This can't be, okay, this can't be 4 or 6. So 4 or 6 is out. It could, this can't be 1, 5, 9 this way. This can't be 2, 5, 8 this way. There's no 1, there's no 2. There's no 4. This has to be 3, 5, and 7. So this has to be 3, 5, 7 this way. And you have a 5, but the 4 doesn't work. The 6 doesn't work. So it has to be 2, 8, or 1, 9. The 1s are removed. So this is 2 and 8 going this way. So this one's done. 22 going this way. The 6 is valid. The 4 is not. This can't be 1, so this has to be the 1 now. Because of Sudoku, we have a 5, 6, 7 combo here. Which eliminates 5, 6 everywhere else. In box 9. This can't be 1, this can't be 1. The 1 has to be one of these two. We have 4 and 6. This can't be 4. None of these could be 4, so this has to be the 4, which means this is the 6. So this is 1 and 9 here. This can't be 1, 9. No 1, 9. This can't be 9. This is 3, which makes that 6, which makes that 1. So this can't be 3. This is 2, 7, 8. This is 2, 7, 8. Okay. So both 15s are taken care of. So we have 2, 5, and 8, and 3, 5, 7. The 25 is taken care of with a 4, 5, 7, 9, and the 15 is taken care of with a 2, 5, 8. The 12 is taken care of with a 4 and 8. The 7 is taken care of with a 1 and 6. 2 is not valid either way. 8 is valid to add up to 14. You can't have 1, 2, 3, 8 anymore. You could have 6, 8. 6, 8 seems fine, and that probably is the solution. What about any other 8s? 1, 7, 8. You can't have a 1 here. 3, 5. And there's no 5, so it has to be 6 and 8. So this is 6 and 8 to form the 14. So the 14's done. What about the 7? You can't have 1, 6. You can't have 2, 5. You can't have 3, 4. You can't have 1, 2, 4. So this has to be 7 then. So that's 7. So the 7's taken care of. 11's taken care of. Because it's 5 and 6. 3's taken care of. 15's taken care of. 13 is taken care of. 6 is taken care of. 7's taken care of. 12's taken care of. 9's taken care of. 15 this way is taken care of. 15 this way is taken care of. 5 is taken care of. 25 is done. 14 we just did. 6 is taken care of. This is either 1, 3, 4, which is still possible, or 1, 7, which is also possible. So the 8's not done. 22 with a 6. So we just have the 8 and the 22 left. Okay, so now... okay, we now start doing some more Sudoku. This is 1 and 9. This is 1, 8, 9. This is 8 or 9. Here, so we have a 1, 8, 9 triplet. So there cannot be a 1, 8, and 9 in the rest in column 6. So this has to be 2, 3, 5, 7. Let's eliminate the possibilities that are removed from Sudoku. 2, 3, 5, 7. So we have 1, 9, 1, 9. 4 is one of these. No 1, 9. Could be 2. No 3. No 6. Could be 4, 5, 7, 8. This can't be 2. Actually, there's no 8. There's no 8 here. So 8 has to be one of those two, right? Which we already knew. 1 is no longer valid. 9 has to be one of these two. If 9 is here, you only have 6 as the highest hit point correct there. So that would be 6, 3, 2, 1, which is not possible. So 9 has to be over here. So this is 15. So that we have 7 now. 1 and 6 is taken out. 2 and 5 is taken out. 3 and 4 is taken out. So it has to be 6, 7. And this is 2 or 5. This is 2 or 5, which means this can't be 2 or 2. So this is 7. This is 8. This is 2. This is now 1. So we have the 22 taken care of, which is 6, 7, and 9. So this is 3, 5, and 8. The 7's taken care of. The 14's taken care of. We just have the 8. And this can't be 1, 7 anymore, so this has to be 1, 3, and 4 to add up to 8. So this can't be 4. This can't be 3. This is 2, 5. Oh, we have a problem. Oh. Okay. Well, we made one bad assumption. That's better than previous ones. Okay, so the 1. So this has to be 1 then. Or do we? No, actually, this is 1, 5, and 8. This is 5 and 8. This is 1, 5, 8. Okay. I don't know how I messed that up. Anyways. Again, the 9. If the 9 is here, this has a similar effect. So this logic is still the same. So this is 9. You have 6 and 9, so that's 15. Then you have to add at least 3 digits that add up to, or 3 digits at most that add up to 7. 1, 2, 4 is eliminated, so there can't be 3 digits. 1, 6 is eliminated. 2, 5 is eliminated because this can't be 2. That can't be 5. And 3, 4 is eliminated. Therefore, it has to be 7. So that's 7, which makes this 2, 5, 2, 5. This can't be 2. This can't be 2. Therefore, this is the 2. This is 1. And this becomes a 3, 5, 8. So that can't be 8. This is 2. 1, 7, 1, 7, 8. So, what are the values potentially? So again, this 15, what are the ones that are left? So the 22 is now done. We have 1, 7, which it cannot be anymore because this 7 is there. So that has to be 1, 3, and 4. So this is 1, 3, this is 4 to add up to 15. Or to add up to 8. I don't know why I said 15. We have 2, 5, 7, 8, but this cannot be 2. This could be 5, 7, 8. This could be 2, 5, 7, 8. This could be 2, 5, 7, 8. That can't be 2. This is 5, 7, 8, 5, 7, 8, 5, 7, 8. This is the only possibility for 2, so that's 2. Um, hmm. This can't be 3. This can't be 3. Couldn't be 3 anyways because of the positioning for the hit points, but... Oh, we have 9 this way. That seems fine. All of these seem kosher. Uh... This can't be 1, this can't be 1. None of these can be 1. Where's the possibility for 1 in row 8? It has to be here, so this can't be 1, which means this is a 9, this is a 1. This can't be 1, this is a 5, 8 pair in column 6, which means none of the other cells can have an 8, so this is, or 5 or an 8, so that's a 7, this is an 8. This has to be 3 and 9. And this can't be 3, so this is a 9, this is a 3. We have a 5, 7 pair here. This can't be 7, so this is 5, that's 7. So this can't be 5 or 9. This can't be 7, this can't be 7. This can't be 6. 1 has to be one of these two, and it can only be here. So this is 1. We have 3, 4, 5, and 9. This can't be 8, so this has to be 5. So this can't be 5 anymore. This can't be 5 anymore. It's a 7, 8, 7, 8 pair. So no 7, 8s in the rest of the box. So it's 1, 4, 5, and 6. No 1 and 6. This is 4 and 5. This has to be 1 and 6. Oops. This can't be 1. This is 1 and 6. So it's 4, 5, which means that can't be 5 in column 9 because we have a 4, 5 pair. So that's a 2. This is a 5. This is 3, 7, or 8, but it can't be 7 because we have 7 here. So this is 3 and 8, which means this can't be 8. So this is 3, this is 8. This is 7, this is 8. So this can't be 8. This is 2, 4, 9. This is 2, 4, 9, so it can't be 2 or 4. So this is 9. Therefore, this is 2 or 4. This is a 2 or 4. This can't be 6 here. We have 5, 6, 7. This can't be 7, so it's 5 or 6. This is 5, 6, 7. In column 8. Now we're just really doing Sudoku here. This can't be 1, so this is a 6. This is a 1. This can't be 6. This can't be 5, so this is 4. This is 5. This can't be 4. There's a 2, 8, 2, 8 pair. This has to be 4, 6, or 9. So this is 4 and 6. This is 4, 6, or 9. This can't be 8, so this has to be a 5. That's an 8 then. This can't be 5. This can't be 7. This has to be 6. So this can't be 6. It's 5 and 7. We have 2, 4, and 9. This can't be 9, so this has to be the 9 in the column. This can't be 4, so this is 2, 4, 2. This can't be 2, so this is 8. This is 2. This can't be 8. Where's the 8 in row 4? It has to be here. This can't be 8 again. This is not 5, so this has to be 3. So this is 5 then. This can't be 5. We have 4, 6, and 7 here, so this is 4 and 7. This has to be 4 or 9. It cannot be 9, so this is 4. This is 9. This can't be 9. 5, 6. This is 4, 5, and 6, but it cannot be, or 7. No, there's no 7. This can't be 7. So this is 4, 5, or 6. Can't be 4 or 6, so this is 5, which makes that 6, which makes that 7, that 5. This has to be 3, yeah. That's the only place for 3. This has to be 6, this is a 4, that's 3 in the corner, and that's a 7. That was not easy for me. I also don't, this is like my first time really drilling into the hit points rule set. So it was, but even then, it was, there are some problems there. Anyways, I hope it wasn't too painful for you to sit through my solve, and I hope you enjoyed it. And I'll see you next time on Frank Puzzles. Take care.